Today we will be deriving the derivative of cosine. My name is Christian, and let's get started. So we can first let f of x equal the cosine of x, and according to our limit definition of the derivative, f prime of x equals to the limit as the change in x, or delta x, approaches 0 of f of x plus delta x minus f of x over delta x. If you do not know how I got this, I made a video called Picturing the Limit Definition of the Derivative, and I will make sure to link that in the description below. So now we can just use cosine of x here. We can say that the limit as delta x approaches 0 of cosine of x plus delta x minus cosine of x all over delta x. So here with the cosine of x plus delta x, just like we did with sine, for cosine we can use the cosine angle sum formula. So this will just be cosine of x, cosine of delta x, minus sine of x, sine of delta x. Okay, so applying the angle sum formula for cosine, we'll get the limit as delta x approaches 0 of cosine of x, cosine of delta x, minus sine of x, sine of delta x, minus cosine of x, all over delta x. So again, just like we did with the derivative for sine, we just want to factor out a cosine of x. So we can do cos of the limit as delta x approaches 0, like I wrote that already. We can do cosine of x times cosine of delta x minus 1 minus sine of x, sine of delta x, all over delta x. So here we can just split this into two separate fractions. So we say the limit as delta x approaches 0 of cosine of x times cosine of delta x minus 1 all over delta x minus sine of x times sine of delta x all over delta x. So now we can just use our properties of limits. We can rewrite it as the limit as delta x approaches 0 of cosine of x times cosine of delta x minus 1 over cosine of x minus the limit as delta x approaches 0 of sine of x times sine of delta x all over delta x. So now, again, just like we did with the derivative of sine, this is the limit as delta x, or the change in x, approaches 0. So if this is delta x approaching 0 here, we have cosine of x and sine of x. We can treat these, cosine of x and sine of x essentially as constants. Now, again, what I mean by that is we can just take these, we can take these outside the limit here and rewrite it as cosine of x times the limit as delta x approaches 0 of cosine of delta x minus 1 over delta x minus sine of x times the limit as delta x approaches 0 of sine of delta x over delta x. So now we see here that these are two special trig limits here. Okay, if you what I mean by this is this would equal 0 and this will equal 1. If you do not know how I got these, how I got the limit as delta x approaches 0 of cosine of delta x minus 1 over delta x to equal 0, and the limit as delta x approaches 0 of sine of delta x over delta x, equals 1. I will be linking, deriving special trig limits, part 1 and part 2, in the description below, which goes over, all the special trig limits that you really need to know here. So after this, we can just rewrite it as cosine of x times 0 minus sine of x times 1. So then we can say that therefore f prime of x equals to negative sine of x. So really the process is exactly the same. The thought process, perhaps, is exactly the same as, deriving the derivative of sine. Like you use your angle sum formula, you, use properties of limits, treat the terms that do not have delta x involved as constants. So it's really just the same sort of, mindset or thought process, when deriving both the derivative of sine and cosine. I would say that for the other trig derivatives, which I'll be covering in the next video, those you do not have to use the limit definition of the derivative, although it is possible to. And you'll see what I mean. Hopefully you can also, before even watching that video, you can start to think like, I know the derivative of sine and cosine. How could I derive the derivative of tangent? Or cotangent, or the reciprocals of both sine and cosine. So start to think about that maybe before watching the next video called Deriving Other Trig Derivatives. So yeah, uh, anyway, hopefully you enjoyed and understand.